Hello everyone, welcome back to the channel, The Chronicles of Current Affairs. Today we are going to talk about earthquakes, tsunamis, and volcanoes. But before we go into understanding what is earthquake or tsunami or volcano, let us learn an important theory called as plate tectonics. A German scientist named Alfred Wegener published 2 articles about a concept called continental drift in 1912. He suggested that 200 million years ago, a supercontinent called Pangaea began to break into pieces, its parts moving away from one another. The continents we see today are fragments of that supercontinent. To support his theory, Wegener pointed to matching rock formations and similar fossils in Brazil and West Africa. In addition, South America and Africa looked like they could fit together like jigsaw puzzle pieces. Wegener didn't have an explanation for how continents could move around the planet, but researchers know this now and proposed the theory of plate tectonics. In some ways, Earth resembles a giant jigsaw puzzle. That is because its outer surface is composed of about 20 tectonic plates, enormous sections of Earth's crust that roughly fit together and meet at places called plate boundaries. By running computer simulations of plates' movements, researchers can estimate where the continents will likely be in the future. Because tectonic plates move very slowly, only a few centimeters per year on average, it takes a long time to observe changes. Scientists have found that the continents will likely again be joined together in about 250 million years. Researchers have dubbed this future continental configuration as Pangaea Proxima. According to World Atlas, 7 major plates exist: the North American Plate, Pacific Plate, Eurasian Plate, African Plate, Indo-Australian Plate, South American Plate, and Antarctic Plate. However, according to a 2012 article in Nature, earthquakes over the last few decades are indicating that the Indo-Australian Plate has cracked over the last 10 million years, creating a separate Indian Plate and Australian Plate, which will increase the number of major plates to 8. Whether that new divide counts as a boundary or not, the Pacific Plate is still the largest of all tectonic plates. It measures 103 million square kilometers in size and lies hidden beneath the ocean. Global seismicity patterns had no strong theoretical explanation until the dynamic model called plate tectonics was developed during the late 1960s. This theory holds that the Earth's upper shell, or lithosphere, consists of nearly a dozen large, quasi-stable slabs called plates. The thickness of each of these plates is roughly around 80 kilometers. The theory transformed the Earth science by explaining many phenomena, including mountain-building events, volcanoes, and earthquakes. In plate tectonics, Earth's outermost layer is made up of the crust and upper mantle and is broken into large rocky plates. These plates lie on top of a partially molten layer of rock called the asthenosphere. Due to the convection of the asthenosphere and lithosphere, the plates move relative to each other at different rates, from 2 to 15 centimeters per year. There are many different types of plate boundaries. For example, sections of crust can come together and collide, forming a convergent plate boundary, spread apart forming a divergent plate boundary, or slide past one another forming a transform plate boundary. Each of these types of plate boundaries is associated with different geological features. At convergent boundaries, plates collide with one another. It could be a collision between 2 continental plates, or between 2 oceanic plates, or between continental and oceanic plate. When collision occurs between oceanic crust and continental crust, oceanic plate subducts under continental plate, creating a deep seafloor trench. At convergent boundaries, continental crust is created and oceanic crust is destroyed as it subducts, melts, and becomes magma. Convergent plate movement also creates earthquakes and often forms chains of volcanoes. The Mediterranean island of Cyprus formed at a convergent boundary between the African and Eurasian plates. Oceanic plate descends into the Earth's mantle, melts in the mantle's hot magma, and is spewed out in a volcanic eruption. Many spectacular volcanoes are found along subduction zones, such as the Ring of Fire, that surrounds the Pacific Ocean. The highest mountain range above sea level, the Himalayas, was formed 55 million years ago when the Eurasian and Indo-Australian continental plates converged, is an example of continental to continental collision. Here, slightly heavier Indian plate subducts under Eurasian plate and pushes the Eurasian plate to raise and form Himalayan mountains. Since density difference between 2 plates is not much, there is no formation of volcanic events. When 2 oceanic plates converge, a deep trench such as the Mariana Trench in the North Pacific Ocean is formed. It is believed to be the deepest point on Earth. These types of collisions can also lead to underwater volcanoes. As the name suggests, divergent boundaries are tectonic boundaries where plates diverge or are tugged apart. In the ocean, this same process creates mid-oceanic ridges. Hot magma from Earth's mantle wells up at these ridges, forming new ocean crust and shoving the plates apart. Underwater mountains and volcanoes can rise along this seam, in some cases forming islands. For example, the Mid-Atlantic Ridge runs directly through Iceland. Maps of the ocean floor showed a massive undersea mountain range that almost circled the entire Earth. An American geologist named Harry Hess proposed that these ridges were the result of molten rock rising from the asthenosphere. As it came to the surface, the rock is cooled, making new crust and spreading the seafloor away from the ridge in a conveyor belt motion. Millions of years later, the crust would disappear into ocean trenches at places called subduction zones and cycle back into Earth. Magnetic data from the ocean floor and the relatively young age of oceanic crust supported Hess's hypothesis of seafloor spreading. This motion creates giant troughs on land, such as the East Africa Rift. This raises a question: is Africa splitting into two? A transform plate boundary occurs when two plates slide past each other horizontally. A well-known transform plate boundary is the San Andreas Fault, which is responsible for many of California's earthquakes. Have you ever wondered what is earthquake and why earthquakes occur? An earthquake, also called a quake, tremor, or temblor, is the shaking of the surface of Earth resulting from a sudden release of energy in the lithosphere that creates seismic waves. Tectonic earthquakes occur anywhere on the Earth where there is sufficient stored elastic strain energy to drive fracture propagation along a fault plane. The sides of a fault move past each other smoothly and aseismically only if there are no irregularities or asperities along the fault surface that increases the frictional resistance. Most fault surfaces do have such asperities, which leads to a form of stick-slip behavior. Once the fault has locked, continued relative motion between the plates leads to increasing stress and, therefore, stored strain energy in the volume around the fault surface. This continues until the stress has risen sufficiently to break through the asperity, suddenly allowing sliding over the locked portion of the fault, releasing the stored energy. This energy is released as a combination of radiated elastic strain seismic waves, frictional heating of the fault surface, and cracking of the rock, thus causing an earthquake. There are three main types of fault, all of which may cause an interplate earthquake: normal, reverse, and strike-slip. Normal faults occur mainly in areas where the crust is being extended, such as a divergent boundary. Earthquakes associated with normal faults are generally less than magnitude 7. Reverse faults occur in areas where the crust is being shortened, such as at a convergent boundary. Reverse faults, particularly those along convergent plate boundaries, are associated with the most powerful earthquakes, megathrust earthquakes, including almost all of those of magnitude 8 or more. Megathrust earthquakes are responsible for about 90% of the total seismic moment released worldwide. Strike-slip faults are steep structures where the two sides of the fault slip horizontally past each other. Transform boundaries are a particular type of strike-slip fault. Strike-slip faults, particularly continental transforms, can produce major earthquakes up to about magnitude 8. Magnitude and intensity are not directly related and are calculated using different methods. The magnitude of an earthquake is a single value that describes the size of the earthquake at its source. Intensity is the measure of shaking at different locations around the Earth. Intensity values vary from place to place, depending on the distance from the earthquake and the underlying rock or soil makeup. The first scale for measuring earthquake magnitudes was developed by Charles Francis Richter in 1935 and reports earthquake magnitudes as Richter magnitude or Richter scale. Earthquake magnitude is a measure of the amplitude of the seismic waves generated at earthquake source and recorded by seismographs. For every unit increase in magnitude, there is a roughly 30-fold increase in the energy released. For instance, an earthquake of magnitude 6.0 releases approximately 32 times more energy than a 5.0 magnitude earthquake, and a 7.0 magnitude earthquake releases 1,000 times more energy than a 5.0 magnitude earthquake. An 8.6 magnitude earthquake releases the same amount of energy as 10,000 atomic bombs of the size used in World War II. The longer the length and the wider the width of the faulted area, the larger the resulting magnitude. The most important parameter controlling the maximum earthquake magnitude on a fault, however, is not the maximum available length, but the available width, because the latter varies by a factor of 20. It is estimated that around 500,000 earthquakes occur each year detectable with current instrumentation. About 100,000 of these can be felt. Larger earthquakes occur less frequently. Earthquakes are frequently associated with reports of distinctive sounds and lights. The sounds are generally low-pitched and have been likened to the noise of an underground train passing through a station. The occurrence of such sounds is consistent with the passage of high-frequency seismic waves through the ground. Occasionally, luminous flashes, streamers, and bright balls have been reported in the night sky during earthquakes. These lights have been attributed to electric induction in the air along the earthquake source. The 1976 Tangshan earthquake, which killed between 240,000 and 655,000 people, was the deadliest of the 20th century. The Great Chilean Earthquake, 1960. According to the United States Geological Survey, the 1960 Valdivia earthquake, also known as the Great Chilean Earthquake, is the strongest earthquake ever recorded. It hit the Valdivia town in southern Chile on May 22, 1960, and its magnitude was measured at 9.5. The earthquake also spawned a deadly tsunami which took the combined death count to an estimated 5,700 in Chile alone. The calamity left around 2 million homeless and caused damage worth about $550 million. The tsunami killed 61 people in Hawaii, 2 on the U.S. West Coast, and 139 in Japan, as per the National Centers for Environmental Information. Great Alaskan Earthquake, 1964. The 9.2 magnitude Great Alaskan Earthquake is believed to be the second most powerful earthquake to hit the region. It is also known as the Good Friday earthquake. It struck southern Alaska in the U.S. on March 27, 1964, and lasted for about 4 minutes, causing widespread damages, especially in the Alaskan capital of Anchorage. According to reports, around 115 people died due to the earthquake. 2004 Indian Ocean earthquake and tsunami. On December 26, 2004 at 7:59 a.m. local time, an undersea earthquake with a magnitude of 9.1 struck off the coast of the Indonesian island of Sumatra. Over the next 7 hours, a tsunami triggered by the quake reached out across the Indian Ocean, devastating coastal areas as far away as East Africa. Some locations reported that the waves had reached a height of 30 feet or more when they hit the shoreline. The tsunami killed at least 230,000 people across 13 countries, with Indonesia, Sri Lanka, India, Maldives, and Thailand sustaining massive damage. Indonesian officials estimated that the death toll in their country alone ultimately exceeded 200,000, particularly in northern Sumatra's Aceh province. The 10 largest recorded earthquakes have all been megathrust earthquakes. However, of these 10, only the 2004 Indian Ocean earthquake is simultaneously one of the deadliest earthquakes in history. Tsunami is a Japanese word for harbor wave. When the epicenter of a large earthquake is located offshore, the seabed may be displaced sufficiently to cause a tsunami. The usual immediate cause of a tsunami is sudden displacement in a seabed, sufficient enough to cause the sudden raising or lowering of a large body of water. The first of these waves is often preceded by an extraordinary recession of water from the shore, which may commence several minutes or even half an hour beforehand. Amplitude, or the height of waves, does not exceed a few meters in deep water, and the wavelength may be on the order of hundreds of kilometers. Correspondingly, the principal wave period, that is the time interval between arrival of successive crests, may be on the order of tens of minutes. Because of these features, tsunami waves are not noticed by ships far out at sea. When tsunamis approach shallow water, however, the wave amplitude increases. The waves may occasionally reach a height of 20 to 30 meters above mean sea level at the shore. Tsunamis may also be created due to landslides. Large volcanic eruptions along shorelines such as those of Thera and Krakatoa have also produced notable tsunamis. The most destructive tsunami ever recorded occurred on December 26, 2004, after an earthquake of 9.1 magnitude displaced the seabed off the coast of Sumatra. A massive tsunami with waves up to 30 m high devastated communities along the surrounding coasts of the Indian Ocean. It had the longest duration of faulting ever observed, between 8 and 10 minutes. It caused the planet to vibrate as much as 10 millimeters and also remotely triggered earthquakes as far away as Alaska. More than 200,000 people were killed by a series of waves that flooded coasts from Indonesia to Sri Lanka and even washed ashore on the Horn of Africa. It remains the deadliest natural disaster of the 21st century. The first warning sign of a possible tsunami is the earthquake itself. However, tsunamis can strike thousands of kilometers away, where the earthquake is felt only weakly or not at all. Also, in the minutes preceding a tsunami strike, the sea sometimes recedes temporarily from the coast. However, not all tsunamis cause this disappearing sea effect. In some cases, there are no warning signs at all. The sea will suddenly swell without retreating, surprising many people and giving them little time to flee. The word volcano is derived from the name of Volcano, a volcanic island in Italy whose name in turn comes from Vulcan, the god of fire in Roman mythology. A volcano is a rupture in the crust of Earth that allows hot lava, volcanic ash, and gases to escape from a magma chamber below the surface. On Earth, volcanoes are most often found where tectonic plates are diverging or converging, and because most of Earth's plate boundaries are underwater, most volcanoes are found underwater. For example, a mid-oceanic ridge, such as the Mid-Atlantic Ridge, has volcanoes caused by divergent tectonic plates, whereas the Pacific Ring of Fire has volcanoes caused by convergent tectonic plates. Volcanism away from plate boundaries has been postulated to arise from upwelling diapirs from the core, mantle boundary, 3,000 kilometers, 1,900 miles, deep within Earth. This results in hotspot volcanism, of which the Hawaiian hotspot is an example. Volcanoes are usually not created where two tectonic plates slide past one another. Large eruptions can affect atmospheric temperature as ash and droplets of sulfuric acid obscure the sun and cool Earth's troposphere. Historically, large volcanic eruptions have been followed by volcanic winters, which have caused catastrophic famines. The Ring of Fire is a tectonic belt of volcanoes and earthquakes. It is about 40,000 kilometers long and up to about 500 kilometers wide and surrounds most of the Pacific Ocean. The Ring of Fire contains between 750 and 915 active or dormant volcanoes, around two-thirds of the world total. About 90% of the world's earthquakes, including most largest, occur within the belt. The Ring of Fire is not a single geological structure. It was created by the subduction of different tectonic plates at convergent boundaries around the Pacific Ocean, including South American Plate, the Pacific Plates, Eurasian, and Australian Plate. The interactions at these plate boundaries have formed oceanic trenches, volcanic arcs, back-arc basins, and volcanic belts. The four largest volcanic eruptions on Earth in the Holocene epoch, or after the Ice Age, all occurred at volcanoes in the Ring of Fire. A volcano needs a reservoir, also known as magma chamber of molten magma, a conduit to allow magma to rise through the crust and a vent to allow the magma to escape above the surface as lava. The erupted volcanic material, lava and tephra, that is deposited around the vent is known as a volcanic edifice, typically a volcanic cone or mountain. The most common features of a volcano is of a conical mountain, spewing lava and poisonous gases from a crater at its summit. The structure and behavior of volcanoes depend on a number of factors. Few such volcanic shapes are. Volcanic fissure vents are flat, linear fractures through which lava emerges. Shield volcanoes, so named for their broad, shield-like profiles, are formed by the eruption of low-viscosity lava that can flow a great distance from a vent. They generally do not explode catastrophically, but are characterized by relatively gentle effusive eruptions. Since low-viscosity magma is typically low in silica, shield volcanoes are more common in oceanic than continental settings. Example would include the Hawaiian volcanic chain. Cinder cones result from eruptions that build up around the vent. These can be relatively short-lived eruptions that produce a cone-shaped hill perhaps 30 to 400 meters high. Most cinder cones erupt only once. Sunset Crater in Arizona is an example of cinder cones. Stratovolcanoes are tall conical mountains composed of lava flows and tephra in alternate layers, and hence the name stratovolcanoes. Eruptions from such volcanoes are explosive. They are also known as composite volcanoes because they are created from multiple structures during different kinds of eruptions. Classic examples include Mount Fuji in Japan and Mount Vesuvius in Italy. The lavas of stratovolcanoes are higher in silica and therefore much more viscous than lavas from shield volcanoes. High silica lavas also tend to contain more dissolved gas. The combination is deadly, promoting explosive eruptions that produce great quantities of ash, as well as pyroclastic surges like the one that destroyed the city of Saint-Pierre in Martinique in 1902. A supervolcano is a volcano that has experienced one or more eruptions that produced over 1,000 cubic kilometers of volcanic deposits in a single explosive event. Such eruptions occur when a very large magma chamber full of gas-rich, silicic magma is emptied in a catastrophic caldera-forming eruption. A supervolcano can produce devastation on a continental scale. Such volcanoes are able to severely cool global temperatures for many years after the eruption due to the huge volumes of sulfur and ash released into the atmosphere. They are the most dangerous type of volcano. Examples include Yellowstone caldera in Yellowstone National Park and Valles caldera in New Mexico, USA. Fortunately, supervolcano eruptions are very rare events. Submarine volcanoes are common features of the ocean floor. Volcanic activity during the Holocene epoch has been documented at only 119 submarine volcanoes, but there may be more than 1 million geologically young submarine volcanoes on the ocean floor. In the deep ocean basins, the tremendous weight of the water prevents the explosive release of steam and gases. However, submarine eruptions can be detected by hydrophones and by the discoloration of water because of volcanic gases. Mud volcanoes are formations created by geo-excreted liquids and gases, although there are several processes which may cause such activity. The largest structures are 10 kilometers in diameter and reach 700 meters high. Boyuk Kanazadag and Toragay in Azerbaijan are examples of such volcano. The material that is expelled in a volcanic eruption can be classified into three types. Volcanic gases, a mixture made mostly of steam, carbon dioxide, and a sulfur compound, either sulfur dioxide, SO2, or hydrogen sulfide, H2S, depending on the temperature. Lava, the name of magma when it emerges and flows over the surface. Tephra, particles of solid material of all shapes and sizes ejected and thrown through the air. Emission of gases like carbon dioxide and sulfur. Volcanic gases can reach the stratosphere, where they form sulfuric acid aerosols that can reflect solar radiation and lower surface temperatures significantly. Sulfur dioxide from the eruption of Huayna may have caused the Russian famine of 1601 to 1603. Chemical reactions of sulfate aerosols in the stratosphere can also damage the ozone layer, and acids such as hydrogen chloride and hydrogen fluoride can fall to the ground as acid rain. Excessive fluoride salts from eruptions have poisoned livestock in Iceland on multiple occasions. Ash thrown into the air by eruptions can present a hazard to aircraft, especially jet aircraft where the particles can be melted by the high operating temperature. The melted particles then adhere to the turbine blades and alter their shape, disrupting the operation of the turbine. This can cause major disruptions to air travel. The 1815 eruption of Mount Tambora created global climate anomalies that became known as the year without a summer because of the effect on North American and European weather. The freezing winter of 1740, which led to widespread famine in Northern Europe, may also owe its origins to a volcanic eruption. Although volcanic eruptions pose considerable hazards to humans, past volcanic activity has created important economic resources. Tuff formed from volcanic ash is a relatively soft rock, and it has been used for construction since ancient times. The Romans often used tuff, which is abundant in Italy, for construction. Volcanic ash and weathered basalt produce some of the most fertile soil in the world, rich in nutrients such as iron, magnesium, potassium, calcium, and phosphorus. Volcanic activity is responsible for emplacing valuable mineral resources, such as metal ores. Tourism associated with volcanoes is also a worldwide industry. Thank you for watching. Please like, share, and subscribe.